Introduction. Why some sources win. Every day, AI search engines process millions of queries and must decide which sources to cite. This decision is not random. AI systems evaluate potential sources using sophisticated frameworks that assess trustworthiness, expertise, and reliability. Understanding this source authority framework is your foundation for all geo work. Mastering this framework will help you understand why certain content consistently appears in AI responses while other content remains invisible. Traditional SEO relied heavily on backlinks as authority signals, where numerous links to a page indicated authority. While backlinks still hold some relevance, AI search engines now evaluate authority through a broader, more nuanced framework. The core principle is that AI engines prioritize sources demonstrating trustworthiness, expertise, accuracy, and transparency. This is because AI systems are accountable for the information they present to users. And citing unreliable sources quickly erodes user trust. Pillar 1. Recognized expertise. AI engines meticulously assess whether a content creator demonstrates genuine expertise in the subject matter. This evaluation goes beyond superficial indicators, looking for concrete evidence of knowledge and experience. Expertise signals include author credentials, such as degrees, certifications, and professional experience, which provide a verifiable foundation for their claims. Professional affiliations with recognized institutions also lend significant weight, indicating peer acceptance and industry involvement. Furthermore, a track record of published work in the field, including peer-reviewed research, signifies a consistent contribution to the body of knowledge. Peer recognition, evidenced by citations from other experts or speaking engagements at reputable conferences, reinforces an author's standing. Finally, the depth of coverage in their content, providing comprehensive treatment of complex topics, demonstrates a thorough understanding that AI systems value for authoritative responses. Case study: Dr. Andrew Huberman. Dr. Andrew Huberman, a neuroscientist at Stanford University, exemplifies recognized expertise and has become a frequently cited source in AI responses concerning neuroscience, health, and performance. His verified academic position as Stanford faculty, coupled with his extensive published peer-reviewed research, provides strong foundational authority. He consistently demonstrates a clear ability to explain complex scientific topics in an accessible manner, making his content highly valuable for AI systems seeking understandable yet accurate information. Huberman is transparent about his sources and studies, often referencing specific research in his discussions, which further enhances his credibility. His consistent content across multiple platforms, including podcasts and social media, reinforces his presence as a leading voice in his field. When users query AI platforms like ChatGPT or Perplexity about topics such as sleep optimization or focus enhancement, Huberman's content frequently appears because every authority signal he presents is robust and verifiable. Pillar 2. Content accuracy and fact-checking. AI engines prioritize sources with proven accuracy and clear fact-checking processes, as this directly impacts the reliability of their generated responses. Strong accuracy signals include explicit citations and references, often linking directly to primary sources and research studies. The presence of clear correction policies, outlining processes for fixing errors, demonstrates a commitment to maintaining factual integrity. Regular content updates, reflecting new information and scientific advancements, are also crucial indicators of accuracy. Furthermore, the display of third-party fact-checking badges, where applicable, provides external validation of content reliability. Most importantly, the substantiation of major claims with verifiable evidence, rather than mere assertions, is highly valued by AI systems. These elements collectively assure AI engines that the information they are processing is dependable and well supported. Case study: Mayo Clinic. Mayo Clinic consistently appears in AI responses for health-related queries due to its exceptional accuracy signals and robust content framework. All content published by Mayo Clinic undergoes rigorous review by medical professionals, ensuring clinical precision and up-to-date information. Each article clearly displays publication and review dates, providing transparency about its currency and validation status. This meticulous approach establishes a strong foundation of trust for AI systems. Their content extensively cites medical research, linking to primary studies and authoritative sources, which allows AI to verify claims. Complex medical topics are explained in plain language, making the information accessible to a broad audience while maintaining scientific integrity. Regular updates reflecting the latest medical guidelines further ensure the content remains relevant and accurate. This comprehensive accuracy framework contributes to Mayo Clinic appearing in a significant percentage of health-related AI responses. Pillar 3. Transparent sourcing. AI engines highly favor content that clearly shows where information originates, as transparent sourcing builds trust and allows for verification. Inline citations providing direct links to sources within the content are a strong signal of transparency. The inclusion of comprehensive bibliography sections or lists of references at the end of articles further reinforces this commitment. Direct links to primary sources, such as original research, raw data, or official documents, are particularly valuable for AI systems seeking foundational evidence. Methodology disclosure, explaining the research methods used to gather information, adds another layer of transparency. This is especially important for original studies or analyses presented in the content. Additionally, clear conflict of interest statements disclosing any potential biases demonstrate ethical practice and enhance overall trustworthiness. These transparency signals enable AI systems to confidently attribute information and assess its credibility. Pillar 4. Domain and site authority. The overall reputation and authority of your domain significantly influence the likelihood of your content being cited by AI engines. Established domains with a history, often indicated by domain age, tend to be viewed as more authoritative. Consistent publishing of high-quality content over time signals ongoing relevance and commitment. Topic consistency, focusing on a specific area of expertise, helps AI systems categorize and trust your domain within that niche. External recognition, such as backlinks from other authoritative sources and mentions by reputable entities, serves as a powerful validation of your domain's credibility. Brand recognition, where your entity is a known name in the field, further enhances authority. Finally, robust security measures like HTTPS, clear privacy policies, and professional infrastructure contribute to a perception of trustworthiness and reliability, which are critical for AI citation. Pillar 5. User experience and accessibility. How easily AI systems and human users can access and process your content directly impacts its citation likelihood. Fast loading speeds are crucial, as slow pages can hinder AI crawlers and negatively affect user experience signals. Mobile optimization, ensuring responsive design across various devices, is essential given the prevalence of mobile browsing and AI's preference for mobile-friendly content. A clear, logical content structure, using appropriate headings and formatting, allows AI to quickly identify and extract key information. Readable formatting, including appropriate fonts, spacing, and contrast, improves both human and machine readability. Crucially, content should have no access barriers to AI crawlers, meaning paywalls or restrictive logins should be strategically implemented or avoided for publicly intended content. Clean code with semantic HTML and proper markup, along with minimal intrusive elements like excessive pop-ups, further enhances accessibility and processability for AI systems. EAT in the age of AI. Google's EAT concept, encompassing expertise, authoritativeness, and trustworthiness, was later expanded to EEAT with the addition of experience. This framework directly translates to AI search, but with important modifications and enhanced emphasis. AI engines now highly value first-hand experience and practical knowledge, meaning content that demonstrates real-world application ranks higher than purely theoretical content. This experience aspect is crucial for showing genuine understanding beyond academic knowledge. Expertise in the AI age means demonstrable subject matter expertise through verifiable credentials, a strong publication history, and profound depth of knowledge. Authoritativeness is assessed by how often others in the field recognize you as an authority through citations, mentions, and references. Trustworthiness is evaluated by the transparency, accuracy, and overall reliability of information provided over time. Together, these elements form the comprehensive EEAT framework that AI systems use to gauge content credibility. Building digital authority signals. Strategically building authority signals that AI engines recognize is a multifaceted process involving both short-term and long-term tactics. In the short term, 0 to 3 months, focus on adding detailed author bios with credentials and expertise to your content. Implement citations and references to existing content, and refresh publish dates to show recent review. Adding schema markup for authors and organizations helps AI understand your identity. Improving page experience by fixing technical issues also provides quick wins. Medium-term tactics, 3 to 9 months, include building content depth through comprehensive resource centers and establishing expertise patterns by consistently publishing in your focus area. Actively seeking quality mentions from authoritative sources and creating original research or data analyses are also crucial. Long-term strategies, 9 to 24 months, involve building strong brand recognition, earning industry awards or speaking opportunities, and developing a rich content ecosystem with interconnected resources. Cultivating a professional network and creating citation-worthy assets like unique tools further solidifies your authority. Understanding the machine, input to output. To effectively optimize content for AI engines, it is essential to understand the journey your content undertakes from a web page to an AI-generated response. This understanding doesn't require becoming a machine learning engineer, but rather grasping the practical mechanics that influence whether AI chooses to cite your content. This process can be broken down into 3 distinct stages: information retrieval, information processing, and response generation. Each stage presents unique opportunities and challenges for content creators aiming for GEO success. The first stage, information retrieval, involves the AI interpreting a user's query, searching indexed content or the web, filtering relevant sources, and extracting text. The second, information processing, tokenizes text, analyzes context, assesses relevance, extracts facts, and evaluates source authority. Finally, response generation synthesizes information, composes the response, selects citations, scores confidence, and formats the output. Each stage is a gatekeeper for your content's visibility in AI responses. 3-stage processing model. The first stage, information retrieval, is where the AI begins its quest for answers. When a user submits a query, the AI first analyzes the question to understand its intent. It then executes a search across its indexed content or performs real-time web searches to find potential sources. These candidate sources are then filtered and ranked based on their relevance to the query. And finally, the pertinent text is extracted from the selected sources. For content creators, this means your content must be easily discoverable, accessible, and clearly relevant to common queries within your domain. The second stage, information processing, involves the AI reading and comprehending the retrieved content. Text is broken down into processable units called tokens, followed by contextual analysis to identify relationships between concepts. The AI assesses the information's relevance to the original query, extracts key claims, data points, and insights, and critically evaluates the authority and reliability of each source. This stage highlights the need for content that is structured for easy comprehension, with clear, extractable information. The final stage, response generation, synthesizes insights from multiple sources, composes a coherent response, selects specific sources for attribution, and formats the output. Your content must provide site-worthy information that boosts the AI's confidence in its generated response. Training data versus real-time retrieval. Understanding the distinction between training data and real-time retrieval is paramount for an effective geo strategy. Large language models, LLMs, are initially trained on vast datasets collected before a specific cutoff date. This training data knowledge is static, broad, and covers an enormous range of topics, but it can be months or even years old. Critically, information derived solely from training data is unattributed, meaning no specific source citations are possible, as the knowledge is blended from millions of sources. For your content to influence training data, it must be publicly accessible during collection periods, and high-quality, authoritative content is more likely to be integrated. In contrast, modern AI search systems supplement their training data with real-time retrieval through live web searches. This knowledge is dynamic, reflecting current information, and is specific to the exact user query. Importantly, real-time retrieval is attributed, with sources explicitly cited, and can include very recent content. This is your primary optimization target for GEO. Focus on creating content that is optimized for discoverability and citation during these real-time searches, as this offers a direct and controllable path to AI visibility. Attention mechanisms and source selection. Attention mechanisms are fundamental to how large language models, LLMs, determine which parts of input text are most relevant to a user's query. Conceptually, it's similar to how a human reader focuses on key sections of an article to answer a specific question, while skimming less relevant parts. LLMs employ sophisticated mathematical attention mechanisms to achieve this. Content that directly matches the query intent, providing clear answers, is highly prioritized. Information positioned prominently, such as in titles, headers, and first paragraphs, also captures more attention. Furthermore, clear factual statements, especially those supported by evidence, are weighted heavily. Structured information, like lists and tables, is easier for the AI to process and therefore receives more attention. Finally, content that mentions relevant entities, specific names, places, or concepts central to the query helps the AI connect information to its knowledge graph. Optimizing for attention means making your most important, site-worthy information prominent and easily digestible, ensuring the AI focuses on what matters most. Context windows and information prioritization. Context windows define the maximum amount of text an LLM can process at any given time. While modern LLMs like GPT-4 and Claude 3 boast very large context windows, often equivalent to tens of thousands of words, it's important to remember that AI systems frequently process multiple sources simultaneously. When an AI needs to synthesize information from numerous web pages, the effective space for each individual source becomes limited. This necessitates strategic information prioritization within your content. When the AI must choose what to include in its processing, higher priority is given to content directly matching the query intent, information from highly authoritative sources, and recent content for time-sensitive queries. Well-structured, easily processed information and unique insights not available elsewhere also receive preference. Conversely, tangentially related content, redundant information, lengthy contextual backgrounds, and poorly structured or outdated content are given lower priority. Therefore, structure your content so the most important, site-worthy information appears prominently and is easily extractable, even if the AI only processes portions of your page. How AI systems handle ambiguity. When confronted with unclear or conflicting information, AI systems employ various strategies to navigate ambiguity and provide the most reliable response. One primary strategy is source authority weighting. If different sources present conflicting facts, the AI assigns higher weight to more authoritative sources. For instance, if a reputable medical institution contradicts a random blog, the AI will prioritize and cite the medical institution due to its established authority. This ensures the AI's response is grounded in credible information. Another strategy is consensus detection. If multiple independent sources agree on a particular fact, that information is considered more reliable and is likely to be presented as the consensus view. When certainty is low or information is still debated, AI systems use qualification and hedging language, such as according to some sources, or research suggests, to accurately reflect the uncertainty. For highly controversial topics, AI may even present multiple viewpoints, attributing each to its respective source. For optimal citation chances, provide clear, definitive information when appropriate, acknowledge uncertainty transparently, cite evidence, and align with expert consensus. Welcome to the citation economy. We are now operating in a new paradigm where visibility in AI search is not primarily about traditional ranking position, but rather about citation frequency. In the era of traditional search engines, the ultimate goal was to appear first on page 1, as that position garnered the vast majority of clicks. However, in the AI search landscape, being cited directly within the AI's generated response is everything. This shift defines the citation economy, a system where the value of your content is measured by how often authoritative AI systems choose to reference or attribute your content or brand. This new economy prioritizes direct attribution and trust. Unlike traditional search where a user might click through to your site, an AI citation means your brand and content are directly presented as a source of truth within the AI's answer. This creates a powerful authority halo effect around your brand. Understanding and optimizing for this citation economy is critical for any content strategy aiming for relevance and impact in the age of generative AI. Why citation matters more than ranking. The visibility difference between traditional SEO and AI search is profound, underscoring why citation now matters more than ranking. In traditional SEO, even the top position on page 1 might only capture around 28% of clicks, with lower positions receiving significantly less. Furthermore, a large percentage of traditional searches are zero-click, meaning users find their answer directly on the search results page without visiting any website. This limits direct traffic and brand exposure for most content. In contrast, when your content is cited in an AI search response, your brand receives exposure to 100% of the query viewers. AI responses typically cite between 3 to 8 sources, offering multiple opportunities for attribution. This citation creates a significant authority halo effect around your brand, positioning you as a trusted expert. Crucially, citations can drive high-intent traffic, as users who see your content cited by an AI are often actively seeking specific, verified information or recommendations, leading to more qualified visitors to your site. Anatomy of citable content. What makes content truly citation-worthy for AI systems? It comes down to specific, identifiable characteristics that make information easy to extract, verify, and attribute. First, clear, definitive statements, supported by evidence, are highly preferred. AI systems favor content that makes unambiguous claims, such as email marketing generates an average ROI of $42 for every $1 spent, rather than vague assertions. This precision allows AI to confidently present facts. Second, quantified information, including specific numbers, data points, statistics, timeframes, and comparisons, is highly citable. Third, practical, actionable information, especially how-to guides or frameworks, is frequently cited because it provides direct utility. Fourth, original research or unique data, proprietary information found nowhere else is citation gold. Fifth, expert analysis or interpretation adds significant value beyond raw information. Finally, current and updated information with recent published dates and fresh data matters significantly for many query types, ensuring the AI provides the most relevant and timely responses. Citation rate, the new key metric. In the citation economy, citation rate emerges as the new key performance metric, replacing traditional search engine ranking positions. Citation rate is defined as the percentage of relevant queries where your content or brand is explicitly cited by an AI system. It is calculated by dividing the number of queries where you are cited by the total number of relevant queries tested, then multiplying by 100. For example, if your content is cited in 23 out of 100 relevant queries, your citation rate is 23%. Interpreting citation rates provides a clear measure of your GEO success. A rate below 5% indicates low visibility and a significant need for optimization, while 5 to 10% suggests emerging visibility. A rate of 10 to 20% signifies strong visibility and a competitive position, and 20 to 30% indicates market leader status. Achieving above 30% means you're a dominant authority in your niche. It is important to note that citation rates can vary significantly across different industries, query competitiveness levels, and AI platforms, so benchmarking against competitors is crucial. Category-specific citation strategies. Different content categories require tailored citation strategies to maximize their impact in the AI economy. For informational content, the focus should be on providing comprehensive, well-cited information with clear definitions and data-backed explanations. Updates should occur annually or whenever information changes. Navigational content, aimed at helping users find a specific website or page, relies on strong brand authority and official information, with updates as business details change. Commercial content, where users research products or services, needs detailed comparisons, pros and cons, specific use case recommendations, and transparent methodology, updated as products evolve. Transactional content, for users ready to make a purchase, requires current pricing, availability, clear calls to action, and real-time updates. Local content, focused on geographic specificity, needs precise location details and local expertise, updated as business details change. Understanding these category-specific needs allows you to optimize your content for the unique citation triggers relevant to each type, increasing the likelihood of being chosen by AI systems for specific user intents. Making your content readable by machines. Creating authoritative and citable content is only half the battle. If AI systems cannot easily access and process it, that content remains effectively invisible. Content accessibility for AI consumption is about systematically removing any barriers that stand between your valuable information and the AI engines. This concept operates on two crucial dimensions: technical accessibility and structural accessibility. Both must work in harmony for optimal generative engine optimization, GEO, performance. Technical accessibility ensures that AI systems can physically reach and read your content, addressing issues like crawl blocking and page performance. Structural accessibility, on the other hand, focuses on whether AI systems can easily extract and understand the information once they have access, involving aspects like semantic HTML and clear heading hierarchies. A holistic approach to both technical and structural accessibility is essential to ensure your content is not only valuable, but also consumable by the AI systems that will ultimately cite it. Technical accessibility, opening the doors. Technical accessibility is the foundational layer, ensuring AI systems can physically reach and read your content without encountering roadblocks. The first major barrier is crawl blocking, where AI systems cannot cite content they cannot access. Common issues include restrictive robots.txt files, content hidden behind login requirements, or heavy JavaScript rendering that some AI crawlers struggle with. Geographic restrictions can also prevent access. Solutions involve allowing legitimate AI crawlers, providing public summaries of gated content, implementing server-side rendering, and ensuring global accessibility. Page performance is another critical technical aspect. Slow loading pages can limit crawl budget, cause incomplete crawling due to timeouts, and negatively impact authority perception through poor user experience signals. Aim for page load times under 3 seconds and optimize metrics like largest contentful paint, LCP, first input delay, FID, and cumulative layout shift, CLS. Quick wins include image optimization, browser caching, minimizing CSS/JavaScript using CDNs, and lazy loading. Finally, mobile accessibility is paramount as AI systems increasingly prioritize mobile-optimized content, requiring responsive design, readable fonts, and fast mobile loading speeds. Structural accessibility, making content processable. Once AI systems can technically reach your content, the next challenge is ensuring they can efficiently understand and extract information. This is where structural accessibility becomes critical. Semantic HTML structure, utilizing HTML5 elements like content text and communicates the content's purpose and hierarchy to AI systems. This allows AI to differentiate main content from navigation or sidebars, identify publication dates, and understand authorship. A clear heading hierarchy, using characters through tags correctly, creates a logical outline that AI systems follow, helping them grasp the content's organization and main topics. Descriptive, keyword-rich headings that are informative, even when read standalone, are particularly effective. Structured data and schema markup explicitly tell AI systems what information means, rather than just what it looks like. Core schema types like article schema and FAQ schema provide metadata that AI can immediately understand, such as headlines, authors, publication dates, and question-answer pairs. This direct communication of meaning bypasses complex parsing. Content chunking and modularity also significantly enhance processability. Breaking content into logical, self-contained units, such as using bulleted lists or short paragraphs for each distinct point, makes information independently extractable. This allows AI to cite specific points without needing to process an entire lengthy paragraph, improving efficiency and citation likelihood. Semantic HTML and heading hierarchy. Semantic HTML5 elements are crucial for structural accessibility, as they explicitly communicate the meaning and purpose of different parts of your content to AI systems. Elements like for self-contained content, for thematic groupings, for introductory content, and for concluding information provide a clear roadmap for AI crawlers. This allows AI to distinguish between the core content and ancillary elements like navigation or sidebars, ensuring it focuses on the most relevant information. Properly used semantic tags also help AI identify publication dates and authorship, contributing to the source authority framework. Equally important is a clear heading hierarchy, which functions as a content outline that AI systems can easily follow. The quote H1 tag should be used only once per page for the main title, with H2 for major sections, H3 for subsections, and so on. This logical progression helps AI understand the relationships between different topics and subtopics. Common mistakes, such as using multiple H1 tags or skipping heading levels, confuse AI systems. Best practices include using descriptive, keyword-rich headings that are informative, even when read out of context, and maintaining a consistent, logical hierarchy throughout your content. Structured data and content chunking. Structured data, implemented through schema markup, is a powerful tool for explicitly communicating the meaning of your content to AI systems. Instead of relying on AI to infer meaning from context, structured data directly labels entities and their attributes. For instance, article schema clearly defines a page's headline, author, and publication dates, while FAQ Schema makes question and answer content easily extractable for conversational queries. This direct communication significantly improves AI's ability to understand, categorize, and cite your information accurately. We will delve deeper into schema implementation in Module 5, but understanding its role in structural accessibility is fundamental. Content chunking and modularity are equally vital for making your content processable. This involves breaking down information into logical, self-contained units, rather than presenting it as a wall of text. For example, using bulleted or numbered lists for multiple related items, step-by-step processes, or feature comparisons makes each piece of information independently extractable. Similarly, tables efficiently present comparative or quantitative data, allowing AI to extract specific data points and comparisons, even within paragraphs, aiming for 3 to 5 sentences with a clear topic sentence and supporting details enhances readability and processability for both humans and AI, ensuring high information density without being overly dense.